if x is a continuous random variable that follows the normal probability distribution, and we have to find out the probability at certain x values, then we always have to integrate the probability density function of the normal probability distribution to find out the probabilities, which sometimes gets more complex. Therefore, an easier way is to convert a random variable x into a standard normal random variable and this transformed function is much easily integrable, as well as we have the standard normal the tables for the standard normal probabilities available, which we can use. So in this module, we will learn how to use the tables for the standard cumulative standard normal probabilities to find out the probabilities at certain z-score values. Over here, this table is the table for the cumulative probabilities. And from now on, as we know that for the continuous random variable, the probabilities are always measured as area under the curve. So I will be using the area as a term to represent probabilities. So if we want to find the cumulative area that corresponds to a z-score of 1.15, then in this table of cumulative probabilities, firstly, we look at the column side, where we will look at 1.1. And then we move across the row to the column under 0.05, which will give us the area to the left of z equals to 1.15. And this area will be 0.8749, which is also shown in the normal curve. We're 0 in the middle. So this shaded area gives us the probability of z being from any value that is less than equals to 1.15. In another case, as we know that a random variable x ranges from minus infinity to plus infinity, and the same is the case with the standard normal random variable, that it goes from minus infinity to plus infinity. So z-score can definitely take a value that is negative. So if by any chance the z gets the value minus 0.24, then firstly we find minus 0.2 in the left hand column, and then we move across the row to the column under 0.04, and hence the area to the left of z will be minus z equals to minus 0.24 is 0.4052, and again in the normal curve it is represented by the shaded region. Whenever we need to find out the probability using z-scores and the table for the cumulative probabilities, I first suggest that sketch the standard normal curve and shade the appropriate area under the curve for which we want the probability for. Secondly, find the area of the following direction for each case shown below. That if we are interested in finding out the area to the left of z, then we find that area corresponds to z in the standard normal table that has the cumulative probabilities. And in the case if z is equals to 1.23, then the area to the left will be 0.8907. In another situation, if our interest is to find out the area to the right of z, then using the table for the standard normal cumulative probabilities, the area, firstly we find the area to the left of z is equals to 1.23, which is 0.8907, and then we subtract it from 1. And as we know that the total area under the normal curve is 1, that's why we subtract the area to the left of 1.23 from 1, which is the total area, and this will help us to find out the area to the right of 1.23. Likewise, if we want to find out the area between two z-scores, let's say in this situation we have minus 0.75 and 1.23. And if we want to find out the area between these 2 points, at first we will find the area to the left of 1.23, and we will also find the area to the left of minus 0.75. And then we will subtract the smaller area from the larger area, and hence we will get the area between these 2 points. And in this situation, if z is 1.23 and the other z value is minus 0.75, hence the area between these 2 points at their z scores will be 0.6641. Just a quick review that if we want to find the area to the left of z, we will directly look at the table for the cumulative probabilities, and the value we will obtain from that table will always talk about the area to the left of z score. And if we want to find out the area to the right of the z score, we will firstly find the area to the left of z score by using the table of the cumulative probabilities and then subtract it from 1. And lastly, if we need to find out the area between 2 z scores, then we take the area for those individual z scores and then subtract the smaller value from the larger value.